Assalamualaikum and good morning YouTube. Yeah, today we will learn about the RL circuit. Okay, first of all, to find the RL circuit, we must find the firstly initial current at the t equal to 0, and then the final inductor current is I infinity, and the lastly is the time constant is equal like this. Okay, first of all, we do some example. The firstly example is this circuit. Okay, we have the formula given is IT equal to I infinity plus I positive minus I infinity time by exponent negative t over tau. Okay, first we draw the circuit. T is less than 0. When the t less than 0, the switch is open. Then we remove this item. We remove the power, the I source. We draw back the circuit is equal like this. This is the inductor. When we want to find the inductors IL, we must short the circuit because we find the current, not we find the voltage. Volt, 1 kilo ohm. This is the IL. 1K, and then lastly 2 kilo ohm for the resistor. Okay, firstly we must find the R total. RTH is equal to R1 parallel by R2 plus R3. R1 is equal 2 kilo ohm times 1 kilo ohm over 2 kilo ohm plus 1 kilo ohm plus by what is R3? R3 we get 1 kilo ohm, and then we calculate this RTH. 2 times 1 over 2 plus 1 is equal 2 over 3 kilo ohm plus 1 kilo ohm, and then the RTH is equal 1 kilo ohm 1 plus 2 over 3 is equal 5 over 3 kilo ohm. This is the R total. After that, we redraw the circuit. We something the circuit like this lah. Okay, 5 over 3 kilo ohm. After that, we find the I total of this is equal to 5 volt over the 5 over 3 kilo ohm. That will be equal 3 milliampere. That we know about the I total is similar than with I 0 negative, similar that also similar with the I 0 positive, and then is equal to the 3 milliampere. Okay, after we settle this, we must find the T is greater than 0. We redraw back the circuit. T is greater than 0 is means the switch is off, currently off. Okay, currently off. They have the connection between the I. Can we draw back the circuit? Okay, then 1 kilo. Okay, when the T is over the 0, the switch is currently on. We assume here have a switch, also have a switch. Then we also assume also have a switch at the 5 volt at the voltage supply, and then the voltage supply we remove it. 1K. Then this IL send me like this. Okay. 2K. And then this is 1K. Okay, first of all, we must find the R total is equal to. Okay, find the R total. R total is equal to 1 parallel 1K parallel by 1K, and then parallel by 2K. Okay, 1K we parallel this thing. We assume that we can take lah. We can, what we say in Malay, congak lah. Congak, we can get the 0.5 kilo parallel by 2.k. After this, is equal. We can use the product over sum. Is equal 0.5 times 2 kilo over 0.5 plus 2 kilo is equal to 0.5 times 2 divided by 2 1. Oh, sorry, my bad. I also mistake. This is not the parallel. We must plus. This is because I will draw back the circuit. The circuit is been like this, and then if we parallel this is can what we call they got parallel to series like this. 0.5 kilo plus 2 kilo ohm, and we got 2.5 kilo. Okay, after we like this, we draw back the circuit. We draw back the circuit. After that we find the tau. After we find the R total, we can find the tau. We must find the tau. Tau is equal to L over R. That means the inductor is we got the 2 Henry over 2.5K is equal to 0.8 negative 0.8 milliampere. Okay. Oh, sorry. This is not milliampere. Tau doesn't have the unit. Okay. After this, after we find the tau, we use this circuit to find the I 0.5. Not 0.5, I think. Yes, at 0.5 we use the current divider. Okay. This like this, the circuit is like this. Like this, right? After that, we are already parallel the circuit. We simplify the circuit with the circuit will like this. This is the IL. We must just short the circuit, and then Oh, sorry. Okay, the 0.5. We just put the 0.5 in here. It's okay. 10 milliohm. Okay, we use the current divider. The current divider, we can get that I 0.5. We use the 0.5 for to find the IL, because the resistance is about the at the 0.5 at the IL flow. When the IL flow, we use this resistance. It's equal to negative 10 milliampere times by 2k over the 0.5 times 2k. That will be equal to 20 over 2. Okay, negative 20 over the 2.5. Right? Am I right? Yes, right. I'm never wrong. Kilo. Okay, sorry. Thanks, my friend. After this, negative 20 divided by 2.5k. That we get over negative 8 0.088 times negative 10 power of negative 3 is equal to 0.008 milliampere. Okay, thank you, my friend. This is not milli. This we can got 0.008 ampere, or we can get 8 milliampere. Okay. After this, we take the given formula like this formula. We write back the formula. Okay. I T is equal to I infinity plus I minus by I infinity times by the exponent negative t over tau. And then we sub in the data to this. We sub in the I infinity, this I infinity, sub in into this equation. We get I infinity is IT equal to negative 8 milliampere plus bracket I this we also got 3 milliampere. We sub it into this equation. 3 milliampere minus 8 negative 8 milliampere times exponent negative 1. We use this negative t over the tau is 0.8 milli. And then we settle this equal to 11 milli. Exponent negative t negative 1 over 0.8 shift, and then we got negative 1250 t, then 8 milliampere. To settle this, we can get negative 3 milli exponent negative 1250 t ampere. Okay, that we assume that this is the 3 milliampere, and then this is the negative is equal to, oh sorry, t is less than 0 equal to 3 milliampere, t is bigger than 0 is equal to negative 3 milli exponent negative 1250 t ampere. Okay, so that lastly you can get like this. We assume that the time constant is, the time is 1 second, and then this is the t is less than 0, is smaller than 0. You can get this like 3 milli. We can get the, if the time is 1 second, t negative 3 exponent negative 12501 t 1 second is equal to the time, the t is equal to 0. So we can get the graph. The graph will go down like this to the 0, and then this is the point. Okay, that's all for today. Thank you.